A rational expression is a fraction made up of polynomials. They look like this. This video is going to talk about simplifying rational expressions, and in order to simplify, you have to have really good factoring skills. So if you need to brush up on that before you watch this video, do that. Okay, so how do you simplify a rational expression and why do we care about factoring? To simplify a rational expression, you factor both the top and the bottom, both the numerator and the denominator, and then cancel like terms. Let's talk about how to cancel first. You think it's something straightforward, but a lot of people have minor errors that happen which can end up snowballing into a huge issue. So in order to cancel like terms in a fraction, you have to have one term in the numerator and one term in the denominator. The entire term must be multiplied by the entire rest of the fraction, rest of the numerator, rest of the denominator. And you can only cancel in a one-to-one fashion. So let me give you some examples real quick. Correct ways to cancel. If I wanted to simplify this fraction here, it may help you to write every single term in parentheses. What I mean is this is a -3 times these two factors. -3 is also a factor itself, so I can put it in parentheses. And in the denominator, it's -3x, -3 times x. Technically, this is two separate factors in the bottom. And if you see it that way, it might be a lot clearer how to cancel. You want to cancel an entire set of parentheses, so I can cancel my -3's from the top and the bottom. And that would be my final answer. In the second example, I don't have parentheses again in the denominator, but it's just an x minus 3. I'm not multiplying by anything else. I don't have any other factors down there. I can put this whole thing in parentheses. Unlike before, since there's a minus sign here, I have to use the parentheses to hold it together. Before, it's implied that there's a multiplying here, since you don't see a plus or minus, so I could write it as two separate factors. Anyhow, now I can cancel out my x minus 3's, and this is my final answer. Here are some examples that I see often when students try and cancel and they do so incorrectly. They say, hey, these 2's cancel each other out. Oh, I can cancel these x's now. No, 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 no. Don't do it. No. You can't cancel because this was a +2 and a +2. Nothing was being multiplied here. Well, your 3 is times x, but it's not times this x squared. So you can't just cancel things willy-nilly like that. It has to be multiplied. If there's a plus sign attached to it, it's not going to work. In the second example here of incorrect canceling, they say, hey, there's an x minus 3 on top and an x minus 3 on bottom. No, there's only 1 on top and 2 on the bottom. So if I wanted to cancel that second one on the bottom, I'd have to have a second one on top. It's not being canceled in a one-to-one fashion, so this would be wrong. I don't know when this will happen on part C, but you could say, hey, there's some parentheses here, so that's meaning we're multiplying things. That's good. So I can cancel out my x plus 2's and just be left with an x plus 1. But, again, I'm not sure why you'd ever see this. There's a plus sign here. Usually we don't have plus or minus signs in between there because it's implying that we're multiplying. So this plus sign here throws us for a loop. This x plus 2 on top is not multiplied by the rest of the fraction. It's added to the rest of the fraction. So we can't cancel it. And then this example will show up again, this exact example, when we add and subtract rational expressions. It's halfway through one of the examples we do. Some people say, ooh, look, x plus 3 cancels. And I'm left with, and now 6 minus 5. Done. But, yes, x plus 3 is multiplied by 5. but this whole thing is being subtracted from 6. So you can't cancel it. If I wanted to cancel that x plus 3, I would need all of this in parentheses to say I'm multiplying it by everything else. Okay, so now that I've hopefully cleared things up and not made it worse, let's do some examples of how to actually simplify. So reminder, when you're simplifying rational expressions, you want to factor everything and then cancel. You may need to refresh your memory on the factoring videos again. I will do it really quickly for you to see the work, but I'm not going to talk you through it. I'll factor the numerator down here on the bottom. And in the denominator, so factor everything and now cancel 1 from the top and 1 from the bottom. When it's factored, you want to cancel an entire set of parentheses at a time. And I don't need my parentheses anymore because there's nothing else on top except the 4x plus 1 parentheses. And that there's nothing left on the denominator except x minus 1 factor. So if you want to put parentheses there, I will not count off. It's just kind of weird to see it that way. All right, second example, let's factor and cancel. Factor the top, you need to pull out a 4 first. Remember, GCF. And now difference of squares. And the denominator. If you need to put a parentheses around this 4 to remind yourself that it is a factor itself, it's multiplied by everything else, you can do that. And now cancel 1 to 1, 1 from the top, 1 to the bottom. And this would be, you don't have to distribute on the top, you can leave it separated. All right, let's talk about a few special cases or some tricks that will help you. You can always rearrange whatever you want as long as you're rearranging and keeping the plus and minus signs with them. So there's not a sign in front of this 3x, which means it's implied to be a positive number. I can rearrange it to make it negative 8 plus 3x if I wanted to. Another trick is you can divide out a negative sign, or technically you're dividing out a negative 1. So I can rewrite this equation as, if I divide out a negative 1, it's going to change every single sign. So this would be a negative 7x squared, positive 9x, and negative 8. Or in the example we just did, I could pull out a negative 1, divide out a negative 1, and it would change both of these signs. So that would be a negative 3x and a positive 8. Why do we care about this? It is helpful sometimes when you see these types of problems. You have to simplify them. Okay, well, for part C, there's nothing to factor. They look like they're almost the same, except they have completely opposite signs. So we can't simplify it, right? Unfortunately, it's not that easy. You have to use some of your tricks. In this case, we're going to use this trick here, where we divide out a negative sign. So everything looks like it's the exact same, except their signs are completely opposite. So I can pull a negative 1 out of this top part, and that would change that to a positive 2x and a negative 1. I'm going to leave the bottom as is. You can put parentheses around everything if you need to help clear up what is a factor and what can cancel. And now I can cancel, and I'm left with negative 1. So yeah, this answer is way more simple than that one. You just have to know how to deal with the trick. Let's do another one of those. All right, before we do anything, let's go with our normal factor and cancel. So in the top, nothing factors out because there's no GCF and I can't square root it. But in the bottom, I can divide out a 3, If you want to put parentheses around everything, you can. And look, these two are almost the same, but their signs are completely opposite. So use the same trick we did before. Divide out a -1 from the top, so that would be a -5 and a positive x. I'll put my parentheses to keep it clear. And now again, it's almost the same, but they're a little weirdly ordered. You can use this trick, rearrange. So I can rearrange this set of parentheses and pull the positive x in the front and move the -5 to the back. As long as it stays in the same set of parentheses, you can do that. Now, done. All right, let's do one more example with special tricks. Factor just like normal, so in the numerator I can divide out a 4. These are almost the same, except the 2's have different signs, but the x's are still positive. So this was a trick question. You cannot cancel this at all. If I wanted to be able to cancel it, I would have needed to have something like this or this. Notice here my x's and my 2's are opposite signs. My x's and my 2's are opposite signs. So in these two cases, I can use the trick and cancel things out. Here, the 2's are opposite signs, but the x's aren't, so nothing cancels, and you can actually use either answer, the original one or the factored form.